From 1960 to 1992, the first commercial nuclear power plant in the U.S. was operational. However, in the early 2000s, the project was stopped due to declining interest in the subject and funding issues. Another reason is because of the byproduct, nuclear waste. With its appearance came some concerns from the researchers and those involved, which led to the question, how do we get rid of it? Scientists mainly use geological disposal, which isn't a bad idea as policies were being implemented to dispose of waste. Eventually, this led to the more commonly used option of deep geological disposal, where waste is stored deep underground so that the risk of harming anything is minimized. But what does this all mean? Why do we have to put nuclear waste underground? Nuclear reactors go through something called nuclear fission, a process where unstable fuel, like uranium, gets hit by neutrons. This causes the uranium atom to split apart, releasing energy and even more neutrons. These extra neutrons hit other atoms, causing a chain reaction. The heat of the reactions turns water in the reactor into steam, which powers turbines and generates electricity. However, if the chain reaction isn't controlled, it could lead to a nuclear meltdown. This is the same process used in nuclear bombs and is one of the reasons why reactors use control rods, which help limit the chain reaction.
Ever wondered what this all means for the human body, though? First symptoms may include nausea and vomiting. Nuclear energy can affect the human body in many different ways. Varies depending on conditions such as exposure time, concentration, and how sensitive the affected tissue is. For example, the gastrointestinal system and bone marrow are highly sensitive to such radiation. We refer to this type of poisoning as radiation sickness and how much is absorbed as the absorbed dose. This is caused by either large doses of radiation received over a short period of time, or vice versa, lower doses over long periods of time. Because of such radiation, these can cause mutations and even cancer in the genes. Nuclear energy isn't always that bad. You see, nuclear energy can have some pretty good impacts on the environment, such as being a long sustaining power source. Don't believe me? Uranium 238 has a half life of approximately 4.5 billion years. But in our case, it is irrelevant since a long half life doesn't always mean it's good for a nuclear reaction to occur. Uranium 238 is a very stable material, but only a tiny fraction of it decays at any moment. In simpler words, it doesn't release energy quickly enough to fuel a reactor by itself, but it is used as an alternative compared to other energy resources to help eliminate our emissions. On the flip side, nuclear waste. It sucks. If left unchecked, the effects on the environment not just include carbon emissions, but the risk of contamination of everyday items such as water sources and food supplies. However, improvements with newer technology and research appear, we are able to not only produce less waste, but also a whole new reactor that relies on a different element. In recent times, scientists and researchers in Japan have created a reactor known as a thorium molten salt reactor. That was a whole lie. It was actually made by China, not Japan. My fault. The switch to thorium from uranium was due to the fact that thorium is a much more abundant resource, produces less long lived radioactive waste, offers safe reactor designs, and is harder to weaponize. Although it requires a starter fuel and a new infrastructure compared to uranium reactors, thorium reactors are able to get shut down quickly and safely without human intervention, which, of course, what we want to do when working with such dangerous materials.